Working on a combination of sections 3.1 and 3.2, we're now going to talk about logarithmic functions. So we're going to discover some stuff as we go that I don't want to just put out there quite yet. I want you to see it as we learn about it. The logarithmic function of f with base a is denoted by f of x equals log base a of x. A couple of things I want to point out. Log and x are written regular size on the same level, but where usually we're used to putting an exponent small and up high, with a base of a log, we drop that down low and make it small. It's a subscript. Okay? Next thing I want to point out, log is a function, just like a square root is a function. It's something you do to a number. Plus is a function. The trig functions, sine, cosine, tangent, those are functions of something else. They do not work on their own. There's nothing for them to do. So you have to have an argument is what we're calling this right here. So log base a of argument x. Now, you should recognize these two conditions. A has to be greater than 0, and a cannot equal 1, just like exponentials. In this case, we also have to have a positive argument. X has to be greater than 0. X, as opposed to a, can equal 1. This statement tells you exactly how these two relationships are tied to one another. It's a biconditional statement, if and only if, which means the first piece is only true if the second piece is true, the second piece is only true if the first piece is true. So it says y equals log base a of x, if and only if x equals a to the y power. So we're going to kind of look at that to see how to convert log to exponential form and exponential to log form. So let's say that we have log base a of b equals c. And I realize some of you are probably saying, Ms. Phil, it made so much more sense when you did it with numbers. It will, but I want you to see the pattern first. I'm all about a pattern. So you always start with the base. Megan Trainor had it right, all about that base. You always start with the base. Sorry. The base of my log is written down here, but if I'm changing it to an exponential, when I change this over, my base becomes the base for an exponent. And I use a spiral format. This goes around the outside. So that becomes my exponent. And then spiral around again. And this becomes the solution. So these two equations are two ways to write the same thing. When we solve equations and you balance both sides, so in other words, if I had x plus 3 equals y, and I subtracted 3, then I have x equals y minus 3, same equation written in a different way. All right, the other way around, let's say I have m to the y, actually I was trying not to use y, let's say m to the w equals t. All about that base still. Here's my base, and if I'm changing to a log, then I have to have a log, and the base, m, is down here. Spiral around, m argument t equals w. Okay? Now, in the next part of this, we're going to evaluate logs the same way we did our exponentials. So we're going to plug in 32 where x is. So it says f of 32 equals log base 2 of 32. So let's start off with just putting these straight into the calculator. After we do this, later on, we're going to see another way that we can solve some of these by hand. Some, not all, because some of these things come out to be some really funky numbers, and it's not something you'd come up with on your own. If I'm using the TI and I want to do a log with a base, I'm going to hit the math button. And then I usually hit the up button instead of scrolling all the way down. I just come up from the bottom. And right here, log base, we're going to come up. Oh, I went over instead of up. up to A, or you can hit alpha A, log base, and it gives you a template to fill in. We want log base 2 of 32. 5 is the correct answer. So the answer to this one is 5. Log base 3 of 1. Well, if you use some common sense on this one, we know that this means 3 to some power is going to equal 1, but there's only one power that does that. So we have math up to A, log base 3 of 1 is 0. Now let's use Desmos for a couple of these. So if I want to use Desmos, I am going to use functions, miscellaneous, log base A. It was log base A of 4, no, log base 4, sorry, of 2. Log base 4 of 2. So back down here, anytime you go off the screen, it kind of moves you around. Log base 4 of 2. Make sure it goes in the right spot. 0.5, I prefer a fraction, so I'm going to put 1/2. Okay, and the last one, if you plug that one in, log base 10 of 1 over 100 is going to equal -2. Those are my answers. The next thing we're going to talk about is right here. We're going to evaluate more logs this time, but this time we're using something called the common log. Down here we're using the natural log. So I want to kind of compare those first. The common base is 10, whereas we said earlier the natural base is E. So my logs are going to follow along those same lines. Log base 10 of x is the same thing as a log with no base of x. You don't have to have the parentheses around your argument. It's just a good practice to get into. So our calculator, our TI, has a log button. That is log base 10. Just like when you do a square root, it doesn't have a little 2 in the index, but a cube root has a 3 there. You have that invisible piece of what you're doing. So log of x. When we have a base 10, we usually do not write the base. Log base e of x is equal to what's called the natural log, and that is written ln, is the abbreviation for natural log of x. I usually do my L a little bit curvy because people are forever thinking that it is an I. They don't do it with log, but they do it with len. So for these here, I'm going to put in, for example, this one, log 10, log 1/3, plug all of those in. These are going to be len. Okay, so let's get some answers on these real quick.